Therefore, our group has choose subtopic name
Multithreading model.
My name is Syuhairah binti Muhammad Yusof.
My name is Irma Fazira binti Muhammad Badrin.
I am Alia Amirah binti Marakat.
My name is Shahida Farhana.
And I'm Elsie.
Enjoy the video!
What is multi-threading models? It is a combined system where multiple threads within the same application can run in parallel on multiple processors. The figure below shows the difference between single-thread process and multi-thread process. There are three types of multi-threading models. First, many-to-many relationship. Second, many-to-one relationship. And third, one-to-one relationship. There are advantages and disadvantages of multi-threading. The advantages of multi-threading are a better use of system resources, enhanced performance on multiprocessor machine, and better availability. The disadvantages of multi-threading are increased complexity, difficult to debug, memory intensive, and potential to deadlock.
Many-to-many model. In this model, many user-level threads multiplexes to the kernel thread of smaller or equal numbers. The number of kernel threads may be specific to either a particular application or a particular machine. Following diagrams show the many-to-many model. In this model, developers can create as many user threads as necessary, and the corresponding kernel threads can run in parallel on a multiprocessor. So, this is many-to-many model diagram. Many of user level threads to the many kernel level threads. The many-to-many model multiplexes any number of user threads onto an equal or smaller number of kernel threads, combining the best features of the one-to-one and many-to-one models. Users have no restriction on the number of threads created. Blocking kernel system call do not block the entire process. Process can be split across multiple processes. Individual process may be allocated variable number of kernel threads depending on the number of CPU present and the other factors.
Many-to-one. Many-to-one model maps many user-level threads to one kernel-level thread. Only one thread can access the kernel at a time, so multiple threads are unable to run in parallel on multiprocessors. In this model, the library maps all threads to a single lightweight process. It is mainly used in language systems and portable libraries. The advantages of this model are totally portable, easy to do with few systems dependencies, and efficiency. While the disadvantages of this model are cannot take advantage of parallelism and may have to block for synchronous input and output. For example, is green threads for Solaris 2. This diagram shows that many user-level threads is being mapped to one kernel-level thread.
This diagram shows that how the user-level threads map to the kernel-level threads. The one-to-one model is among the earliest implementations of true multithreading. The one-to-one model creates a separate kernel thread to handle each and every user thread. Most implementations of this model place a limit on how many threads can be created. The library maps each thread to a different lightweight process. Advantages for one-to-one model are scalable parallelism. It is because each kernel thread is actually a different kernel schedulable entity. Multiple threads can run concurrently on different processors. Next, multi-threaded programs written under the one-to-one model can achieve significant speed-ups when migrated from uniprocessor to multiprocessor. The last one is multi-threaded OS interface. Unlike the many-to-one model, threads blocking in the kernel do not impede process progress under the one-to-one model. When one user thread and its kernel thread block, the other user threads can continue to execute since their kernel threads are unaffected. Disadvantages for the one-to-one model are thread creation involves LWP creation. Second, each thread takes up kernel resources. The last one is it limiting the number of total threads. The example of one-to-one model is Windows NT or Windows 2000.
Differences between user level and kernel level thread. For user level thread, it is faster to create and manage, while for kernel level thread, it is slower to create and manage. The second differences is implementation is by thread library at the user level, while for the kernel level thread, operating system support creation of kernel thread. Third differences is user level thread is generic and can run on any operating system, while for the kernel level thread, it is specific to the operating system. The fourth differences is multi-threaded application cannot take advantage of multiprocessing, while for the kernel, its routines themselves can be multi-threaded.
Did you enjoy the video? Thank you for watching. Bye!
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 Bye! Bye!